we've learned how to work out the slope of a line, this video is going to concentrate on how to establish what the equation of a line is. And again, we're going to use y equals mx plus b as the slope-intercept form of a straight line. Remember, the slope is the m and the b is the y-intercept. So in this example, number 1, we can see very clearly that the y-intercept is 2. So all we need to do now is find the slope. So the slope is the rate of increase of the line. So starting at 0, 2, let's try to find out another nice point where it meets the grid exactly. And we can see there's another one here and another one here. It's very plain to see that to get between them I need to go 3 squares across for 1 square up. 3 squares across for 1 square up. The slope is rise over run, which is the increase in y over the increase in x, and clearly the slope is 1 over 3 or 1/3. So the equation of this line is y equals mx 1/3 x plus the y-intercept. Y equals 1/3 x plus 2. We can check that the equation is correct by ensuring that it generates the correct y value for a particular x value. And we can see that one of the points was 6, 4. So when x equals 6, y should equal 1/3 of 6 plus 2. 1/3 of 6 is of course just 2. So y does indeed equal 4. So it seems that this equation is correct. Okay, same again with the second example. Y equals the slope times x plus the y-intercept. We can see clearly that the y-intercept is 5, but we need to work out the slope. And the best way to do this is to try to find nice integer coordinates where it meets the coordinate grid. So moving from one to the other, I can see that I need to go 2 squares across and 3 squares down, and again 2 squares across and 3 squares down. So it's going down 3 for every 2 across. So rise over run is down 3 minus 3 over 2. So the equation of this line is y equals minus 3 over 2x plus 5. We can check that it's correct by seeing whether it will properly generate the coordinates of this point here. When x is 4, y is -1. Well, when x is 4, minus 3/2 times 4 is minus 12/2, which is minus 6, and minus 6 plus 5 is indeed -1. So this does generate the correct points, so this equation is correct. The previous two examples used what is called the slope-intercept form of a line. Now I want to concentrate on the point-slope form. In other words, how to generate the equation given a particular point and knowledge about the slope. So if we actually knew the coordinates of a particular point, I will call it x1, y1, we considered another point with general coordinates x, y, then just like before, the slope of this line is the increase in the y divided by the increase in x. The increase in the y is just going to be the difference in the y coordinates, y minus y1, and the increase in the x will be the difference in the x coordinates, x minus x1. So the slope m will equal y minus y1 divided by x minus x1. And if I wanted to get rid of this division, all I'd do is multiply up, and I'd end up with y minus y1 equals m multiplied by x minus x1. And this is the most useful form to find the equation of a line if we know coordinates that lie on the line and information about the slope. Okay, this is a fairly typical example. Find the equation of a straight line with a slope 2 passing through the point 1, 5. Well, 1, 5 is perhaps somewhere like this, and a slope of 2 means it's rising quite quickly, so it'll look something like that. So the point is 1, 5, and m equals 2. So we had y minus the y coordinate equals the slope x minus the x coordinate. So y minus 5 is equal to 2 times x minus 1. We're just going to expand the right hand side. 2 times x minus 1 is 2x minus 2. And then I'd like to bring this minus 5 over, so y equals 2x minus 2 plus 5, or y equals 2x plus 3. And I can check it's correct because, as we know, when x equals 1, y should equal 5, and if x equals 1, y equals 2 times 1 plus 3, which is indeed 5. Here is a slightly more complicated set of circumstances. The equation of a line with the slope of negative 3 over 2 passing through the point negative 4, 7. Well, negative 4, 7, negative 4 on the x, fairly positive y, is somewhere about here. And a slope of negative 3 over 2 means it's going down faster than it's going across. So it's perhaps something like this. So x1, y1 is minus 4, 7, and m is the slope minus 3 over 2. So y minus y1 equals m x minus x1. So y minus 7 is negative 3 over 2 x minus negative 4. Exactly the same as previously, we've just got to be a bit more careful with the signs. So let's do one thing at a time. Y minus 7 equals minus 3 over 2. X minus negative 4 is the same as x plus 4. When I multiply that bracket out, I get minus 3 over 2x plus minus 3 over 2 times by 4. Well, minus 3 over 2 times by 4 is the same as minus 12 over 2, which is the same as minus 6. So we have y minus 7 equals minus 3 over 2x minus 6, and then I'm going to move the minus 7 across, so I end up with y equals minus 3 over 2x plus 1. If this is correct, when I substitute the x coordinate minus 4 into it, it should generate the correct y coordinate. If I substitute in x equals minus 4, minus 1.5 times minus 4 is plus 6, plus 1 is indeed 7. And finally, using all this to find out the equation of a straight line when we don't actually know the slope of the line, but we do have information about 2 points which lie on the line. Because if we know 2 points, we can then work out the slope and move on from there. So here we have points 4, 7, which is somewhere like that, and 6, 8, which is perhaps somewhere like that. And we want to find out the equation of this line. In order to calculate the slope, the best formula is the difference in the y coordinates divided by the difference in the x coordinates. If we take 6, 8 as x2, y2 and 4, 7 as x1, y1, the slope is going to be 8 minus 7 divided by 6 minus 4. which is a half, and that looks correct from my rough sketch. Now we have two possible coordinates to use in the formula. It really doesn't matter which one, they're both going to be correct, so I'm going to use 4, 7. Y minus y1 equals mx minus x1. So y minus 7 should equal a half x minus 4. Expand the bracket, a half x minus 2. Move the minus 7 over, so y equals a half x minus 2 plus 7, or y equals a half x plus 5. If this is correct, it should properly generate the other point when x is 6, y is 8. Well, if x is 6, half of x is 3, and 3 plus 5 is 8, so this does indeed work. And finally, perhaps the most complicated of all of these, minus 1, 8 is somewhere up here, and 7, negative 2 is somewhere down here. So the straight line that we want clearly has a negative slope and clearly has a positive intercept. Being consistent and careful, so the slope will be y2 minus y1 divided by x2 minus x1, which in this case is minus 2 subtract 8 divided by 7 subtract negative 1. Minus 2 subtract 8 is minus 10, and 7 subtract negative 1 is 8. Minus 10 eighths is minus 5 fourths. It doesn't matter which point we're going to use, for the sake of simplicity, that they're actually both going to have the same issue, so I'll use 7 minus 2. So y minus the y coordinate equals m x minus the x coordinate. So y minus negative 2 will equal minus 5 fourths x minus 7. Y plus 2 equals minus 5 fourths x plus 35 fourths. When I bring the 2 over, it becomes minus 2. 2 is of course 8 fourths, so y is minus 5 fourths x plus 35 fourths minus 8 fourths. So the final equation is y equals minus 5 fourths x plus 27 fourths, or minus 1 1/4 x plus 6 3/4. And there you go. So these 6 examples thoroughly explain how to calculate the equation of a straight line if we know a point it passes through and the slope, or 2 points that it passes through, so we can work out the slope and use that. I encourage you to practice several examples so that you have got this very, very concretely. This is a valuable skill which will be used time and time again. Thank you.